Today we're going to talk about monomials, more specifically about multiplying monomials. So let's take a look at what a monomial is. A monomial is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. And just something to remember today is if it involves division by a variable, it is not going to be a monomial. A constant is also a monomial that is a real number. So up here in our definition where we said a monomial is a number, well, a real number is a monomial. Let's take a look at some of these examples and try to determine whether it is a monomial or not and why. The first one is just the whole number, the real number 10. Well, 10 is a real number, and by definition, a real number is a monomial. So yes, this is a constant, so it's a monomial. The next one says f plus 24. Well, f plus 24 involves addition, not multiplication, so no, this is not a monomial. It's actually an addition problem involving two monomials, and we'll talk more about expressions like this in the near future. The next one is h to the second power. Well, h to the second power means h times h. Well, it's the product of variables, so yes, this is a monomial. The next one is just a single variable. Well, by definition, yes, a single variable is a monomial. So let's take a look at product of powers. Well, product of powers is simply to multiply powers with the same base. And if we're multiplying powers that have the same base, all we have to do is to add their exponents. Let's take a look at a simple example as to why this rule works, just to add their exponents. If I have a to the second power times a to the third power, if I write that in expanded form, I've got a times a times a times a times a. Well, basically that says a to the 2 plus 3 power, because here I have 2 a's, here I have 3 a's, so it's a to the 2 plus 3 power, which is a to the 5th power, which is a times a times a times a times a. So our rule works, so let's just apply that in some examples here. Our first example, we have two monomials. We have 6n to the third power times 2n to the 7th power. Well, the first thing we're going to want to do is we're going to want to group our coefficients together and our variable terms together. So we know that multiplication falls under the commutative property, so I can rewrite it in any order I want. So we're going to do some grouping here. We're going to do 6 times 2. And we're going to do n to the third power times n to the 7th power. Once we do this, I can see that I'm multiplying powers that have the same base here. They both have a base of 10. Our rule says to add their exponents, so I can rewrite this as, well, 6 times 2 is 12, and this would be n to the 3 plus 7 power. Well, 3 plus 7 is 10, so I have 12n to the 10th power. Let's look at a couple more examples before we move on. This next one is 3y to the 4th power times 7y to the 5th. Well, let's group our coefficients and our like terms together. So now I have 3 times 7 times y to the 4th times y to the 5th. Well, 3 times 7 is 21. This would be 21 times y to the 4 plus 5 power. So when I simplify that, that would be 21 y to the 9th power. Let's take a look at this. Now, whoa, a lot more variables here, but it works by the same principle. We're going to go ahead and we're going to group our coefficients and we're going to group our like terms. So let's see what this looks like. It would be negative 4 times negative 6 times r to the 5th times x to the 2nd times x to the 2nd times t to the 3rd times t. Well, we can go ahead and simplify that a little further. We can say 24 times r to the 1 plus 5 power times x to the 2 plus 2 power times t to the 3 plus 1 power. Well, we can go ahead and do the addition, clean it up, and we've got 24 r to the 6th, x to the 4th, t to the 4th. I hope this helps you with multiplying powers that have the same base, and we'll see you in the next video.